invite.
Oh, that's all right. I'll get George in here as well, and then you can ask him, because I were interested in that. And I wanted to do a test YouTube compression thing. Actually, it's more to do with alignment, to be honest. I'm a bit... Yeah. I'm still playing around with my stream
4K.
settings. Well, no,
4K.
no, I'm having to do it. If I ever... Well, put it this way. If I ever did a debate, you know, hosted a debate or something, and someone passed me a presentation, then yes, I absolutely would do it in 4K. But without that, there's no point, because Hangouts only does 720p screen sharing. But if I knew that I was going to be sharing a lot of stuff, then yeah, I'd definitely stream it in 4K. But then the problem is, YouTube doesn't do multi-streams. So even though I'm kicking out at 4K, you have to watch that 4K stream even at 1080 or 720p, which means then you'll start buffering if you haven't got the connection. So it doesn't kind of multiplex it in real time. It just gives the people the 4K stream. So
you mean you're streaming 4K, but I will not be able to see it 4K?
No. It will give you the 4K stream. So let's say it's 10 megabits a second. Yeah?
Yeah.
It will give you the 4K stream at 10 megabits a second, and then downsample it in the YouTube web player on your computer to 1080p if you're viewing it in 1080p, or even 720. But it'll still be using 10 megabits.
Okay, so it will not display as...
Yeah, except it'll take up the bandwidth, which means if you've got a shitty internet connection, then yeah, you're a bit screwed.
Yeah, well, remind me when you do that, I shouldn't be on the other end, because my connection sucks.
Yeah, but sometimes it sucks, but other times it's all right? Like now it's all right.
I don't know. It was really good until I got the PlayStation for the kids, and I don't know what happened. Even when it's turned off right now, it's not something wrong. I don't know.
I don't know what it'll be. The PlayStation sometimes, if there's two modes to, it's a PS4, right?
Yes.
Yeah, so there's two modes to it. There's power off and rest. Power off, everything's off. Rest, which is the fast way to shut it down, it will leave a game running, and it will do periodic checks to the PlayStation Network. It can download games in the background and updates. So if your kids have got, like, let's say 30 games installed on it, odds are there's going to be a new update for those games every day at least. So if it's in rest mode,
room, you know? Yeah, I see the orange lights on, so that's the rest mode, I think.
Yeah, which means it can still be downloading shitloads of stuff in the background. Because what it has, what's brilliant about the PlayStation, this is actually my field, even more so than, you know, George can explain, is the PlayStation has what you call 7 separate processing units, SPUs, on the die on the chip. Now, one of them can be powered independently to the others. So for one of them is used for system monitoring, system maintenance, and downloads in the background. And that's the one that stays awake in rest mode. It shuts all the others down, but it keeps one online in this low power mode to do all the downloads, which is why your connection might be a bit crap.
Yeah, that's a great machine. Welcome, George.
How you doing, George? You're on mute, George. There you go. Oh, you're eating.
Why are you inviting me, Dean? Why are you inviting me, Dean? You don't fucking like me.
I can talk to people that I don't like. No, it's not you that I dislike. Okay. It's just your voice and what you say.
Well, that's pretty much everything. You don't leave much room.
I know, right? Or is it you that doesn't you don't leave much room to like, George? That's the way that I see it.
No, I see. So how's that flat Earth model coming for chemo?
Yeah, I'm not. Yeah, no, that's never going to work. I've had Sean G telling me that it'll help me do it. What I was actually looking at, George, is I wanted to build an animation expression whereby anywhere on the globe that I
Okay.
place a camera, it will change the orbits of the sun and moon
Oh,
to match
I
what
just
we see.
yeah, it just occurred to me, since you have this capability with this building these models,
Hmm.
why don't you just place a camera on what you have, place a camera down at the surface, and watch the sunset?
No, I do.
See what it looks
No,
like.
no, I do. But
Oh,
the problem that I've
oh,
got
okay.
is I've got people
No,
like,
I mean from the viewpoint of the camera.
yeah, no, I do. I'll show you. I'll show you.
Oh, oh, okay,
I've
cool.
already done this. Give me a second.
No con.
The issue that I've got though
Go.
is I wanted to mutate reality so that it works. I wanted to mutate my
No.
model so that it matches reality, and I don't care what I have to do it.
Oh God. Well, I think that's going to be impossible
Well,
because
it's
you
not.
can't.
No, it's not impossible. Inside Maya, I am God. It is not impossible, George. I just have to figure out what it is. So what I was going to do, I'll show.
No, what I'm saying is I don't think there's any mathematical geometrical transformation. Excuse me, that can get you there.
Breathe,
You
George.
might get
No.
close.
Stop talking. I'm going to ban you from talking while you're eating. You'll kill yourself.
Yeah. Um, you might get close. You might approximate.
Hmm.
You know,
All right.
but that's the problem that we have with you know, map projections, Mercator map, or whatever you have. There's just no exact one-to-one transformation that can take you from the surface of the sphere to a flat plane. You're always going to have some compromises. You have to accept some distortion, you
Yeah.
know, of some sort.
So let me just share my screen and I'll show you what I've got at the moment.
And this is the thing these flat earthers don't understand, you know, is that you can't go from a 3D to a 2D plane without accepting some distortion. You know, the Mercator map gives you an accurate representation around the equator.
Yeah. Now, if you look at this,
And
can you see what I'm sharing,
okay,
George?
yeah,
Yeah. So I've got a sun and moon cam. Where are we? Sun cam, and currently I've got it placed. Oh, in Havana. So,
yeah, okay,
yeah. So what I've done with that is, if I switch to my sun cam one, I guess this is this is the
oh, cool,
yeah. Now, but
okay,
what I'm on about is I have the ability to do some, to create
yeah, massage things, yeah,
to do an expression whereby from this viewpoint here, because this camera, no matter where I move it, always looks at the sun. Yeah, that's an animation constraint. I also have the
right.
ability to have an expression that, based on the position of this, can actually mutate the orbits of these as well.
Oh, okay.
Yeah, so
Jeez, what software is
oh,
this? I
just
mean,
my,
this is so cool.
no,
This is what
Maya.
Maya,
Yeah. So
what
yeah,
MYA or M what?
Maya. It's actually people think it's to do with the ancient Mayans, but
Yeah,
it's
yeah,
not. It's actually an
yeah.
ancient word for illusion, believe it or not. But anyway, I've got Python as a programming language inside of this that I could do anything that I want with. But my
Uh-huh.
idea was, if I could get this, if I could set an expression that works in not assume Y is up, that works in Z and X,
Mm-hmm.
that can mutate these orbits of the, wait a minute, let's get both of them, of the sun and the moon, so that they actually match reality based on where this camera is.
Like
Yeah.
change the azimuth and elevate.
The
No,
physical,
just
the physical thing.
the elevation on.
Yeah,
The
but
elevation
then,
Yeah.
on.
what I was going
I
to
don't
do, wait a
know.
minute, listen to this. Then what I was going to do is I was going to do a ghosting of all of that all over the globe, all over the disc. It's not a globe, is it? It's a disc.
Yeah.
But then that would show me how people see it and what it looks like on here to see what kind of shape is formed. Yeah. So for each, so if I imagine I have 100 cameras all spread out equidistant on this, each one of those cameras has a new instance of a sun and a moon, which we class as local to that camera, where the expression drives the rotation of these orbit paths to match reality. Then I get to see this funky shape that it's actually formed on there. That's what I was thinking of doing.
Yeah. Oh, hang on. Shoot. Where the hell's the mute button? Okay.
You get what I'm on about, Khaled.
Yes, I think you're going to use your azimuth. You control the camera for azimuth, no problem. But you control the sun for elevation.
Yeah.
And
so
which
yeah.
in turn controls your camera to
Yeah.
focus.
So imagine if I created 100 cameras and I spread them all out on this disc. Now, for each one of those cameras, I created a local sun and moon that matches that particular geolocation's reality.
That's going to be a mess.
But wait a minute. There's going to be a structure there, isn't there? It might look like a mess, but if I ghost this, in other words, what I can do in Maya is, wait a minute, let me see, animation.
Okay, hold on for a second. You're going to arrange those camera in an organized manner.
Yeah, just like a grid. Yeah, just like a grid.
Yeah, okay, I got you.
So imagine I have one camera. Well, not a grid. I'd do them along latitudes.
Line?
Yeah. So I'd have one at the North Pole, then at about, let's say, let's say 69 degrees, I'd have 10, and then 25, and then all the way out, and then do the local sun and moon. Probably less than that, to be honest, but yeah, do a local one for each. But then not only that, provide ghosting as well.
I don't understand what ghosting.
So give me a second. I shall show you exactly what I mean. Give me a second. Because despite it might look like I know what I'm doing, I stopped using Maya about 8 years ago.
Oh, that's long.
I know.
So why aren't you doing that with what you're currently using?
Because I don't do 3D graphics anymore. I got bored, so I changed to doing computer programming instead. Because I can't remember how to actually do this now. Animation markers, no. Oh, playback. No. It's bloody somewhere. This is pissing me off now.
Oh, take time because I'm trying to join from my laptop. All right, I'm there.
Oh, do you watch it from your phone? Oh yeah, you get a better connection on your phone, don't you?
Too small.
Oh no, that's right. No, so I select both of these. So I've got the sun, moon. So all I need to do is those, and then select animate. Where the hell? Yeah, that is animation. Wait a minute. Yeah, this is annoying me now. Oh, this is so annoying. I used to be so fast at this. It used to be wicked, but now I could have sworn. Maybe not. Wait a minute. It was really good what you... Are you still there, Khaled? Hello? I cannot hear you. You seem to be very quiet. But you're not muted. Which is odd. Oh, right. Ghost selected. Visualize. Jesus. What a piece of shit. Still can't hear you, by the way. Global preferences. Right, you're not there, are you, Khaled? Well, can't hear you. But if you can hear me, this is what I was on about. So I can have these, and these show the paths. And I think it'll show some pretty interesting patterns. Oh, now I can hear you. Oh, I can hear you fumbling around with a mic.
Can you hear me?
Yes. Except you got feedback. You need to mute one of your thingies, I think.
Yes, okay. Yeah, I see. Why my camera is on? Yes, okay. Yeah, I see. Why my camera is on? Yes, I can see you.
Yeah, so this is what I meant by ghosting it. So,
Yes, okay.
yeah, so if I get this to match the reality of somewhere in Cuba... Wait a minute, you're very quiet.
Yes, I can see you.
Yeah, so this is what
Yeah,
I
I
meant
can
by
hear you.
ghosting it. So, yeah, so if I...
Yes.
Yeah, so on this, if I get this to match up with, you know, like this would... Actually, this wouldn't... Oh, Jesus, wait a minute. What do I do in the... What do I do at the North Pole? This is harder than I thought, actually. Bollocks.
Like the model I was trying to...
No, yours is reality. That's fine.
No, the other one. The other flat earth model
Oh,
better.
right, yeah, with the two rings and how it would work. Yeah, bollocks. Weren't it? No, I can do this. No, I can't. Well...
What's the problem with the North Pole?
Well, so the problem is... Oh no, I could do it, couldn't I? No, that's fine. But I've never seen the track through the sky. I was just thinking... No, the North Pole is the only place where this is going to work, isn't it? As in, it might actually match reality. It's 24-hour daylight, but not... but the...
But not exactly the same angle.
Yeah.
Not the elevation angle.
Yeah. Yeah, so what I need is for each lat long, I need to be able to put in and then find the azimuth and elevation for each hour, I guess.
You can get that from the other model, that one in the corner.
Yeah, I could do.
Is there any to take a number between two lines or an angle between two lines and like copy it?
There is, however, in 3D you don't deal with Euler rotation, so you don't have X, Y, and Z. You don't have X, Y, and Z in that terms in degrees, because you get what you call gimbal lock if you start using degrees. So you use quaternion angles, which George should know about actually.
I don't know this.
Yeah, all it means is problem with something in 3D is if you've got this, for instance. Have a look at this. I'll show you the problem in 3D. And this exists if you're using degrees. Yeah. So I've got all I'm doing now is I'm building a gimbal. Yeah.
Yeah.
So this gimbal will deal with certain axial rotations. So I'm going to parent that to that, and I'm going to parent this to that. Which means now this is a proper gimbal that I can do with what I want. Except, so this Z direction here, I can rotate around Z. Everything appears fine. Wicked. Now, if I start rotating this around its position, wait a minute, let me just freeze transformations on these. Yeah, so if I start rotating this around, so I'm rotating an object this way. I'm not doing the other axes. So you can get into gimbal lock by rotating this around, rotating the whole object. And when you start doing other rotations on this, you can get to a point now where you can no longer manipulate in the directions that you want, when you're kind of multiplying angles together. So the way that you fix this is everything is always, it's kind of a, is it a unit vector?
Must fix it this way.
Well, yeah, it's just quaternion, math basically, which is shit. It was actually invented in Ireland, I think, or Wales. But yeah, it solves the problem of dealing with angles, because you know, when you're rotating this that way and you want to rotate this now 45 degrees, well, the problem is it's only 45 degrees if it's relative, but the transform that you're actually making to making this do in world space has got nothing to do with 45 degrees. It's actually a two-axial rotation. But and that's what you get with Euler rotations, or Euler, depends where you're from and what you pronounce it like. So that's why they did quaternions. Yeah, it's going to be an interesting shape if I do this. And I'm still waiting for a flat earther to come and help me build their version of this model, by the way.
Come on, how did he help you?
Well, it can tell me what you know, how high the ice wall is for a start, because at the moment.
Oh, okay. Like some details to work with.
Yeah. Well, the thing is, I don't even know whether this is their map.
Only when it suits them.
Yeah. Yeah, I think they should have a consensus. You should set up a web page where everybody can vote on it. Yeah, so I've got to work on this. What were you saying about George with the Doppler effect? Yeah, you get Doppler distance. You're trying to send a 2 gigahertz wireless signal from point to point when they're moving.
Yeah, they're both moving at the same speed.
And what did George say?
No, he said the frequency return shouldn't change.
Because how fast are they moving?
300 meters per second.
Oh, right, okay.
The calculated change was only 2 hertz, but he said it should be 0, so I should get back to the math again. Initially, I was playing around these things because I wanted to find a way from, or something from our life that we use that can debunk the ether, not just Einstein. But then even when I was reading the definition of Doppler, it says whether you're moving in air or the vacuum of speed, the vacuum of space, that the medium is stationary. So I may have not gone anywhere with that, but I was just trying.
What is so? Is the flat Earth consensus that the ether is something that rotates in this on this plate, basically?
No, I think for flat earthers, ether is just like gravity.
What?
It's yeah, it's something that doesn't exist.
No.
Yes, like
Wait a minute. Are we speculating here, or do you know this? Because everybody else speaks about the ether, and I've really never asked what the hell is this ether. I know it's in the Marvel films. It's one of the Infinity Stones, isn't it? It's the Reality Stone. Is the ether.
oh yeah, yeah.
And that's about it. And they're like, why are they talking about a Marvel film?
No, it's well. First, let me continue what I was saying. Why they think it's something like a characteristic of the globe, and it debunks the globe if it's characteristic of the globe. The ether is medium that uh, electromagnetic waves move through, and if the Earth is moving at 30 kilometers, it will be like if you are moving fast and using like your horns, and the car horns, not your horns. So I'm not sure. Of course, George can explain this better than me. Um they expected in the past that Michelson Morley, someone with that name, he was making an experiment to prove uh, the Earth speed in orbit using that concept of the ether, and he couldn't measure any speed. But then Einstein came and explained it that there's a length contraction or something like that makes the laser or the light get back on the same time to these two sensors that they should record some shift in receiving the light because of the movement of the Earth. Basically, they shoot a beam in the direction of movement, and a beam vertical or perpendicular to the movement, and they spread from a point, go through mirror, and then they get back again. So one of them should be received faster than the other if there was an ether. But that's where Einstein came in.
Right.
We call him Einstein, by the way, in Arabic.
Oh, do you?
Einstein, not Einstein.
Oh, right. Which is the correct pronunciation?
Really? Okay, I know that. The German pronunciation.
Is it?
Okay.
I actually don't know. I don't know how you pronounce his name, to be honest.
You know that gimbal look you showed reminded me of when I was trying to plot the lemma. My belief that the lemma is a result of the vertically the declination angle of the sun in the specific day, and horizontally because the Earth is faster at some times and slower. But when I did that, it came out as a perfect figure of 8. So there was something else, and that something else was the tilt of the Earth, because the tilt and so on makes that perfect figure of 8, but the speed of the Earth makes it bulky from the bottom.
Yeah.
You remember that yellow stripe and blue stripe or red stripe that I showed on that model?
Yeah.
So a specific point on Earth moves 1 degree every day. in relation to the space. You got that?
Yeah.
Because the sidereal day and the solar day. So every day the same point spins or by 1 degree, and the same goes for the subsolar point. It moves also by 1 degree, but because they both on different plans, sometimes one is faster than the other, and the opposite happens every 6 months.
Hmm.
So that created the figure of eight, and the orbit eccentricity made that figure of eight bulky from the bottom. And on my spreadsheet, I actually removed the column that contributes, or the column that's derived from the Earth orbit, and it showed a perfect figure of eight.
I'm going to show you something that's actually quite interesting. So I don't know whether you were watching, but on Anthony Riley was on Jose's show,
All right.
and I can't remember what I was saying to him, but I was trying to get him away from science because, believe it or not, George and Rumpus will kill me, but I don't give a shit about anybody else's definition of science. I give a crap about probability.
Yeah.
So what I did is I said, what's the probability that we are on a spinning globe? I don't give a shit about a scientific test. I just want to know what's the probability. I said, well, we've got loads of observations that we can make that stack either one way or the other. And one of those observations is that the sun does not change angular size at all through the day, or not to any degree whereby that would represent
The flat Earth.
yeah.
Uh-huh.
So Anthony miscorrected me. Well, he said that yes it does, basically. He said yes it does. And I said
Yes.
absolutely no it doesn't to any discernible degree. You might get an error tolerance of about 1 to 3 pixels given an imaging sensor, how it's perceiving it, how it's exposing, and maybe an infinite focus shift or something like that. There'll be an error tolerance, but that will be it, and that's all it will ever be. Now, what he put me in touch with a guy that sent me some images. And I'll tell you what, I shall just show these in a second. Let me just do...
The one showing vertical shrinking.
Yeah, do you know, have you seen Dave Marsh before? I'd never heard of him, to be honest.
Yeah, of course,
Oh,
yeah.
I did not. Yeah, I did not. So let me just do this really quickly. Yeah, it was interesting when I looked at the images, to be honest. I did actually find it quite interesting. Let me share my screen to yourself. Right, here we go. So these were the images that he gave me. Now he also sent me a video. Now what he was doing to measure them somehow was getting them in the world's shittiest program and drawing an area around that gave him kind of either the radius or the surface area, I forget which. But that's ridiculous.
Yes.
That's a terrible way to do it because your tolerance is not pixel perfect on this. It never will be, and it's just not a very great way of doing it. Whereas what is, for anybody that wants to do kind of comparisons and stuff, is first of all level it so that you can accentuate the edge. That's one of the most important things.
Right now I've been seeing it growing and shrinking in front of my eyes. When you were playing with levels.
Yeah. So all I've done is take it down to what I would class as a solid edge. So now I can say merge down, and I'm set. So on this one, I'll also level it to take out the haze, because this haze is going to cause me issues. But I do want to boost the object. So, but I don't want to flare it out. So now I've got this. I'll merge it down, and then I've got this one, which has got a lot of haze, the timestamp's really good. So it's it's really nice that the dude's taken time to do this. I do actually appreciate this quite a bit. But yeah, so here we go, and then I'll merge this down, and then all we do is we overlay them over each other. We don't use some stupid thing to...
Yeah.
And then what we do is we say, give me the difference, because now I'm subtracting one from the other, which means when I start to move this around, and I can do pixel nudging as well, I get an absolute difference. Yeah. So now what you can see is that is the sum of the difference. 1 pixel edge, which is about the same tolerance that I would class as sensor interpolation or sensor excitement. If it's crossing a pixel boundary, you would expect it to fill in one side and not the other based on a very slight angle change. So it's never going to measure the same width of pixels, because it's not the same width that measures perfectly into pixels. So at some point it's going to lose one, add one, lose one, add one, as you're laterally rotating it. So this is the best way to compare them. So I can see that there's hardly any difference. The difference is 2 pixels, if that, which is what I would say.
2 pixels.
Yeah.
Maximum.
Which is what I would give, the error tolerance of the sensor, and it's probably not as much over here, to be honest. Some of it almost blends into one.
Yeah.
So maybe I've got it slightly aligned.
And you're ignoring any atmospheric effects like the heat, and so even the heat can affect the sensor.
That's why I said if it needs to be more than 3 or 4. To me, it needs to be more than 5 pixels, and this is less than 3. And then we've got this one. Now this one's interesting. So I'll compare this to this image. Now this one's interesting because if I add a difference, where's my difference? If I add a difference to this, we can see something incredibly interesting, and that's it's almost the same width, but it's compressed. So if I move it all the way down so that it matches up with the bottom kind of and overlaps, it's compressed it this much, but obviously this is near the horizon.
Yes.
So this is the atmospheric compression, which is pretty cool to be able to, for me to be able to look at this now and say, this is atmospheric compression that's happening now, because it's no longer a sphere.
Yes.
Yeah, I love the way of that. But comparing these and seeing that, I forget what these times were now. What were they? If I go back and say normal, so we've got I think it's 5 o'clock. Yeah, 5 o'clock versus midday. And there's no change hardly at all. But what we can see, and what's interesting, and what I would love to point out to people, is that these digits here that actually move when I do a snap test, a blink test. That shows that it wasn't the same part in the camera as well. So there's 2 other things that are quite important. One is the lens distortion, because depending on what lens it is, then
I didn't think that.
Yeah, but then the other, which is just as important, when you get down to measuring pixels, because these digits, because you move something over a certain range of these actual square pixels. If you move something so that it matches up with half of a pixel, it might not register, or it might act a little bit different, or it might feather it out. It depends on A, the filter on the end of the lens, on how it's interpreted, and B, the color curve profile of the actual imaging sensor. So there's other little things that can mutate it. But either way, you know, I think it's pretty definitive when you expect to see, what is it? You know, you'd expect the difference to be astronomical through the day, wouldn't you? You'd need it. You'd need it half the size or something. It certainly
Yeah.
wouldn't be this. So, you know, in conclusion, this is a big object, a shitload of miles away, an inconceivable distance away.
You know, this exactly his argument that look, there's a change. It reminds me with the Dumb and Dumber. You know which part?
Yeah.
When when he asked her what are chances, chances, she said 1 in a million. So he
So
was
not nothing.
yeah, he was so happy. So we have a chance.
Yeah. But yeah, unfortunately, I mean, I did look at it, and I did look at it. You know how I looked at it in a very, you know, open-minded manner as well. But at the end of the day, I just cannot concede the point that Anthony brought up in the in Jose's hangout. The sun does not change angular size at all. Now, that Dave Marsh has passed me, or he's going to pass me, hasn't sent me them yet, some moon. I think this is why I was asking you, some moon images that he's done. But what I want to do before then is get my orbits of my solar system and the moon correct, because then I'll be able to match them up with that. Because obviously the orbit of the moon, it kind of plots like a flower, a petal, you know, a flower petal shape, doesn't it? Through the day, through each day, or each. I don't know how long I guess procession
In
of it
relation
is.
to the Earth axis.
Yeah. So it's not.
Hello?
Yeah. It's not this set. It's not this set sequence, is it?
You're breaking off, or my connection is bad.
I think your connection might be bad, because I've got plenty of bandwidth, I think. Can you hear me?
Hello? Yes, but is the connection or yours?
I don't know. I can kind of hear you fine.
I think you're talking. Okay, hold on. Let me try again. And can you hear me?
Yeah, you're breaking up a bit though. Yeah, Khaled, I just listened to the stream and it is you that's breaking up. I think your kids' PlayStations are downloading games again. Which I guess is an alright thing. Oh, Khaled. Can't hear you if you're talking, by the way. Oh my god. Do I have the ability to mute George? Oh yeah. I have to try that. That's pretty sweet. Yeah, I can't hear you, Khaled. You ain't. Your mic's not on at all. Don't know why.
Oh, hey there, Dean. Sorry about that.
Oh, pal.
Girlfriend buddy called, try to tell me about his day on the course.
Who called, sorry?
My girlfriend buddy.
Right, okay.
Yeah,
Cool.
never. Well, let's see here. Oh shit, my new passport came. Oh, that's good. Now I can come and visit you in Rumpus.
Oh yeah, you're flying over to Germany, aren't you? But you're going to stop over in the sunny
Well, I don't know if that's
Isles.
going to happen. If I do, it might just be a flight to come here directly. The Germany thing might not happen.
Oh right, really?
Oh, these new passports are kind of cool. The every page has got a background theme of the United States.
Oh, nice.
Bald Eagle, Independence Hall. Uh, Big ships. Kind of cool. Mount Rushmore.
Big ships going over the horizon. Wait a minute, are those ships going over the horizon?
Yeah. This big ship is it's about headed to disappear over the horizon. Yeah. This must be the flat Earth version.
Nice.
God. Well, Ranty really disappoints me. I had a conversation about a month ago or so, Ranty, and showing him how to make measurements and make better measurements and that. And Ranty sounded real receptive, and then this stupid video on diffraction limit. Jesus Christ. These guys, they just doubled down, Dean. You know?
You saw my reply to Nathan Oakley, though, didn't you? Yeah. No, I remember you.
Yeah. But they don't really listen. No, they don't, you know.
He needs money back, really. And I'll lobby for him as well.
Yeah, that was a good comment.
I'm almost.
Yeah, obviously, the money was not well spent on their education. That's obvious.
Yeah. Well, I don't even know what kind of education he has, to be honest. So, just one of those things, I guess.
Not enough, obviously.
Yeah.
I'm sure in Nathan Oakley's case, it's pretty much just show. It's a put on, you know. In his case, just to generate revenue.
Maybe, but the problem, yeah, I mean,
I'm not convinced that he believes. I'm not convinced he believes any of the crap that he spews forth.
Really? Wait a minute. I've got a problem with this hangout. But this is why I'm here, playing around. I can't turn you down, but you're maxing out massively. Like sound-wise, but Khaled wasn't.
Say what?
I can't turn your volume down, even though you're like way loud.
Oh.
I don't
Okay, I'll back away.
No, well, yeah, I was going to say, I don't think it's you. I turned your volume up. Well, I actually muted you to see if I could mute you because I was just playing around, and then I turned your volume up. But then I lost the panel where I've got volume control, so
Okay.
I can't actually.
Well, something that I've got going on here for the past month that's really bothering me is I can't turn my camera on. I can't get any of these Hangouts or Skype to recognize my camera anymore.
Okay. So, are you on Chrome at the moment?
Just a minute. I'm hearing voice in the background. Is that coming from you, or is it something on?
That's you, because I can hear it through your audio.
Just a minute. Check my windows here. Try to figure out where the hell it's come. Ah, it's come from the debate thing. I have. This has been disturbing in Discord for me here too. Is the I can mute it. I can mute all my audio, but yet audio still comes through. So it's a big lie.
I'm just going to try and rejoin, won't I? Nah, speak again, George.
Okay.
Oh, yeah,
I'm
okay.
speaking to you, Dean.
Yeah, no, that's cool. That's better.
Oh gosh.
No, what I was going to say is,
There was a.
Did you see the P Mars thing?
Yeah, I guess he mooned Q online live, huh?
Yeah, that's ridiculous. I was on
He's
Sean
such a
G's.
disgusting
No,
man. I don't know why people
I was on Sean G's Hangout. And
say what?
I was on Sean G's Hangout, and he kept trying to, screw that up by jumping in and being racist and all that kind of stuff. But then Channel Q says, oh, is stalking me? And I'm there like, oh, stalking you mean here? And she goes, no, have a look at the videos on his channel. So I watched like the last two while I was in the Hangout, and it is pretty, it's hate, it's hate speech against Channel Q basically. And then so his so his webpage was left up. So when I finished,
well, she should report him.
I know she's tried 6 times. YouTube have done nothing. You see, the problem is, George, is not that popular. It's like 160 views. YouTube don't give a shit, really. They won't even investigate something that low. If it got 1,000 views or 10,000 views, then yeah, it becomes a serious concern, I think. But yeah, it is just shit, really.
Well, if you talk to Q, tell her talk to me, and I can maybe get something done. I know people.
Well, yeah.
That's all I'll say.
Yeah, I don't think YouTube give a rat's ass, to be honest, for something so small. PMARS is not a...
Are you streaming live right now?
Yeah, I'm playing with the stream as well. That's how... Yeah, well, playing about with controls and stuff. It is just a test. It's just me fucking around again. But yeah, I just went through with...
I don't know what's going on with this video. I'd like to get my...
Oh, no, yeah, so what I was saying is, do you want some support that I can bill you for later? Is if you're using Chrome, so you've got Chrome open right now, yeah?
Yeah.
In the address bar, to the far right-hand side of the address bar is a little star and possibly a camera.
Yeah.
Yeah, so click on the camera.
Yeah. Okay,
and does it say...
Just a minute. Okay, tell me.
Yeah, and then it says microphone allowed, but then there'll be a manage button.
Yep.
And can you go in there and do you see your camera? So at the moment it says microphone, yeah? If you press back, and then you can go to camera, and then it'll say, do you want to allow access?
Screwing up. Am I with you yet?
No.
Okay. Yeah, things keep coming in and out. Okay, I'm in the settings here, looking through. Hangout.
Yes.
Allow.
Yeah, yeah. You're in the camera settings, yeah?
Yes.
Yeah, yeah. Yeah, you just need to say, ask, you've probably got it blocked somewhere and it's not on the allow list.
Well, in the allow list, showing Discord, Hangouts, Google, Meet Google, Plus Google, Messenger, YouTube.
Oh, right, wow. Okay. So what happens when you press on the camera button then?
It tells me, whoops, where the, God, hang on, this is so maddening.
Yeah, so close all that, get back to this Hangouts window and just click on your
I
camera
just,
to say...
I've got to, hang on, there's so much lag in my system right now.
Buy a Mac.
I don't know what's, well, when you're ready, I've been seriously thinking about that.
Yeah,
Maybe
yeah.
we can get a place for 2.
Yeah, except mine's going to be about 8 grand.
Yeah. Well, I mean, we don't have to buy identical models loaded the same way.
Yeah, you wouldn't want mine unless you're doing some pretty serious compilation, which I doubt whether you do you?
No, when I do math and any computations incentive stuff, I use my HP workstations that aren't tied to the internet, my business computers. And that works for me. I don't use PC for doing my business stuff.
No. So are you back on the Hangout now? And when you click that
Yeah,
camera,
I'm getting there now. Yeah, it's going to tell you as soon as it comes up here. Okay. Hangouts doesn't detect the camera connected to your computer without a camera.
right, okay, yeah. So it's just your camera that's not detected at all then.
Yeah, as I say, something broke from one of the previous updates from Microsoft, and I've never been able to get it back.
Share your screen. Make sure there's nothing confidential on your desktop or anything.
No, there's on internet and laptop, nothing's confidential. Let's see where the hell. Cancel this again. Share screen. No, that was chat. God dang it. Okay, here we go. I got to give it a bit here to think about it. Okay, here it is.
Right, so...
All right.
Jesus Christ. What version of Windows is this? This is ridiculous.
7.
Jesus.
7 Ultimate.
Jesus Christ.
Yeah.
Well, you know, if you switched it to the standard theme, it'd actually work better, quicker.
To the standard what? Theme?
Yeah, so...
What do you mean, the standard theme?
Right.
That's what I've got up.
Right, anywhere on you see you've got all these translucent blur effects on the windows.
Yeah.
Do you think that takes up processing power or not? Taking a bitmap and radially blurring it.
Of course it is. Yeah.
So right click on the desktop anywhere and go personalize.
Okay. Come on.
Wow.
Yeah, something's broken.
Yeah, the developers who wrote Windows.
Yeah. Besides that, though, this used to immediately
stop. It's like when someone's got a disease or something, you don't go, oh, they're hot. Let's try and just cool them down or something. You actually find out why they're hot, and then you fix that. The heat is a byproduct, isn't it? It's not the actual cause.
Yeah.
It's a symptom. Windows working like this is a symptom of shit Windows developers writing the operating system.
True.
Holy crap, George. Is this screen still white?
Yeah, it's thinking about it. Like I was saying, something's really broken. You see?
Jesus. Right, so... Oh, Jesus Christ. Right, you see where it's... oh, wait a minute. Let me have a look. Stop. Because I've got to remember how to use this now. Oh, you see basic high contrast themes. Scroll down to the bottom.
Yeah.
And you want the theme on the far left, Windows 7 Basic. Now, normally this takes about 5 seconds to apply. I'm pretty sure that you could go away, have a coffee, make yourself something to eat, take the dog for a walk, and we'd still be here looking at Please Wait.
Well, I was actually thinking maybe just going to get another degree and then come back.
Yeah, so what this does is it turns off all this translucent shit so that the CPU is a little bit freer. Yeah, doesn't really, you
Yeah.
won't notice that much of a
Oh, that's
change.
good.
Yeah, but anyway,
Yeah.
close this now because we're going to do one other thing now.
Close it or just hide for
No,
the
just
time
close it,
being?
close it, close it. We
Okay.
don't need it anymore. You could actually choose Windows Classic if you ever wanted to, and it would go down to even, it wouldn't do gradient
That's what I
fills.
have been using in the past, was the classic.
Yeah.
Or
To be honest, there shouldn't be that much difference between the two. But now if you go click on
Yeah.
Windows, the Windows icon, Start menu, whatever the hell you call it.
you don't want to be in this part
No,
anymore?
I don't.
Okay.
By the way, this is a Mac user telling you what to do here. How interesting is that?
Yeah.
So in search programs, just type device. And we should have, oh, Jesus Christ. This is painful.
Yeah, tell me.
It just gave up as well, didn't it?
Sometimes it does.
Jesus. I've never seen the search, but the progress bar go that slow. This is amazing. It's like I'm watching the world in slow motion. You know when they slow down, like a cheetah running or something. It's like mesmerizing to watch.
I say this has been going on for a couple months now. Before zippy, but something's happened.
Right click on you know your bar at the bottom, the start bar thing, the thing that goes, well, just the whole bottom bar of the screen at the moment. Just right click anywhere on it where there's no icons. Bottom bar, George, where all your icons are, but just in the middle bit. No, not there, not there, not there.
No,
Right,
no. What?
so go down.
Is,
Oh, there's
okay,
your.
it's loaded the window now. It's loaded the window.
Yeah, so that USB camera there. Double click it.
Huh. That wasn't there before.
Yeah, well, we're just having a look. Webcam. Double click it again. Okay, hardware. Because it'll say the it'll say the driver type here as well. Manufacturer. Okay.
All I can say might work now
Just
because
devices.
that never showed up before.
Yeah, I don't know. I think.
Well, let me try it and see. Let's see what happens here.
Yeah, I think it's going to be the same.
Yeah.
Shit. Yeah, just go to settings there. Let's just see if it is listed. Because it could be that it's. No, I meant go back to the Hangouts thing. Settings. Just no. The button there on the blue thing.
Oh,
That says settings. Yeah. Yeah, maybe. Yeah, this is just a bit weird. Maybe it's a shit camera.
No, I've tried other cameras and I get the same damn thing.
All right, cancel that. Just do right. Just last little favour here now. Do a right click on the bottom bar. You know your start menu. You know that bar. Right click on it and go Task Manager. Because I want to know what the hell the leading point of this. Go Processors tab at the top. List by CPU. So tap on, you've got different columns, headers. We've got image name, username, and CPU at the top. Holy crap. Okay, that's really interesting, George. How many Chromes have you got open?
4.
Yeah, this is interesting. There's something very wrong with Chrome. Because if you look at how many processes it spawned there, that's 20, 30.
Yeah, so it's dragging it down.
Yeah, so something's very, very odd there.
Yeah, like
And
I
have a look at
said,
have a look at the memory usage as well as some of these. You've only got one that's like probably high memory usage, which is the
Oh,
Hangouts window. Oh, Khaled.
yeah, I found it. I had to get back to my phone. Sorry.
That's all right. I'm doing tech support with George at the moment. I don't mind being interrupted. It just means that he spends more time, which means my invoice goes up. That's fine. So, this is weird. If you, I was going to say if you, I'm talking to you on Chrome, aren't I? We're going to say if you close Chrome, do all those Chrome processes still run?
I don't like Chrome. That is the one thing that has changed. I wasn't using Chrome before.
We're using Firefox.
Something forced me to install Chrome. I don't remember what it was.
Yeah, that's a bit odd. That is a bit odd.
I think our computers were working fine until you invited us.
Yes, just stay on the line just 10 more seconds and I've got you. It'll be fine. Wait, George.
Yeah.
Stop sharing your screen now. I'm going to show you something.
Okay. Just a minute.
Because, yeah, that's pretty much ridiculous. So, what I'm going to show you is I'm going to take you on a tour of what a real computer looks like.
Well, I know. I've got a better laptop, but I can't get it online because the network blew out on lightning strike, and so I'm on my last resort right here.
Yeah, you need to. Yeah, it's just. I feel sorry for you, and you've got enough money to buy a new damn laptop, George. It'd make your life easier. It'd be less frustration as well. I might have to do a video explaining. You know this life is short thing. Have you seen that, George?
No.
Wait a minute. I'll tell you what. We'll get your opinion on it in a second. Wait a minute. Where are we?
Is this one of your videos?
No. This is a person, a flat earther, or a non-heliocentric person.
Oh, okay. Yeah, I've heard of him. I think he was on a hangout with you once, and if I remember right, this guy was probably dumber than Chris.
No, well,
Or am I thinking of? No, there's another guy, Flat Earth Data.
oh God, yeah, no, he's a bit special.
It's special.
That's the unfortunately, that's my only. I thought it was Life is Short. Khaled, do you know this Life is Short? Have you got his channel or something?
I think so.
Just find it for me because I want George to have a look at his last video, because all flat earthers now quote him as the ultimate authority in everything optics.
Oh, optics. Oh, okay.
Yeah.
Well, this ought to please you.
Well, yeah. Except, so here's the thing. I can explain 3 different aspects that are not part of his presentation that would play a massive role in it. And it'd be interesting for you to look at it, watch the video, you'd have to skip to like the most interesting bits. And it'd be interesting to see what you'd come back with. Because I pretty much guarantee it wouldn't be what I've said.
Is it very long or?
One of them's 38 minutes of him explaining how shit disappears from the bottom up.
Oh gosh.
With equation. Wait a
Like,
minute,
why
George,
in a
George,
nutshell?
George, with
I oh
equations and
wait,
everything.
we all know it's angle of attack.
No,
So
it's got equations and everything. That completely validates it, doesn't it?
oh yes, of course.
Yeah, the second you take, that math thing that isn't reality, the second flat earthers use math, obviously it's the Holy Grail.
Yeah.
It just isn't the Holy Grail when we use it to prove things, but it is when they do. I love that. But I can't.
I'll send it on Skype.
Well, the problem is they
Oh
don't
yeah,
know
do
how
that.
to use equations in the first place, so that makes it even more amusing.
Yeah.
What's this now?
Oh no, that's not. No. Yeah, the one
Is it
that
not the same guy?
Khaled just posted in Skype, George.
That's the
Which
channel, but
one?
I don't
Epi
know.
Takedown?
Wait a minute.
No target.
So 2
No
months.
targets.
Oh my God.
Okay, life's short YouTube video. Okay, I got it.
Yeah, but go to videos, George, and look at diffraction limit. It's only 10 minutes. The rest of them are fucking immense. Like one of them says a concept for vision, and it's 2 hours long.
Okay, just a minute. Oh, I see. I double click. All right, videos.
Diffraction
Angular
limit.
resolution in our world. Angular 1 of 6.
No,
Six.
diffraction limit.
Okay.
Yeah, look at that
What
one.
about this? A concept for vision, not that.
Oh, if you want to spend what 1 hour 57 minutes and
Oh,
16
geez, no,
seconds, then yeah,
no.
sure, George, you go right at that.
No, I very rarely. The only time I ever watch a flat Earth video is when it's brought to my attention, like you are doing now. Is I as a rule, is I never watch any of this stuff because again, life is short.
Yeah.
All right, well, I'll watch this and I'll get back to you. How's that?
Yeah, but
Or do you want to talk
no,
first?
no. Have a watch it, and you can watch his series on them as well and see what you think. But what would be interesting is if you don't discuss it, and we'll have another hangout whereby we can discuss it, and you can tell me what you think. And
Well, with this being 10 minutes, I can get back to you here in just a bit if you want to
oh
talk
well,
about it.
yeah, go for it. Yeah, go for it then.
Yeah. So I'll just mute myself and I'll watch it and then I'll get back to you.
Well, yeah, probably leave the hangout, George, because I might be talking with Khaled.
Oh, that's all right. I can mute.
Yeah, but you won't be able to mute me, will you? Or Khaled?
Yes, I can.
Okay.
Uh-huh.
Okay.
I can go into my mic mixer and just shut your hangout down.
Well, actually, a better way is if you right-click, is it, on the tab on Google Chrome, you should be able to mute it as well, I think. Oh, you can on my version. I don't know whether it's Mac version or anything.
Cat. No, I don't have anything that shows me that.
Well, if you can do it on your mixer, it doesn't really matter.
Unless, no, not
Because you can
there.
mute the site, it says. So if you right
On the tab.
Yeah,
On the tab.
yeah, on the tab at the top in Chrome, if you right click on
Yeah.
it, you can mute the site. You can
Oh, yeah. There is. Mine is grayed out. I don't have that option.
right, okay, no, it doesn't matter then.
So
Have you seen this, Khaled? The Life is Short, the 10-minute version.
I think I must have
I'll be
seen
back
it.
with you.
Yeah.
I must have seen it, but I'm not sure. It's gotta be the reason why I'm subbed to him.
Hmm.
So it's gotta be talking about that diffraction limit. We cannot see objects if they are smaller than a certain size.
Well, the thing is a little bit. Well, the diffraction limit of what he's talking about here is. Wait a minute. Let's have a look at what he's on about. Yeah. So So his argument is that the aperture or physical opening, I think, of the iPhone is small, therefore diffraction plays a huge part in it. Whereas, but anyway, there's some very fundamental things that are wrong in his observation that I think are maybe not honest, or maybe purposefully omitted, or maybe he genuinely just didn't think about it. But there's three aspects of this that he doesn't mention, that he failed to mention, and he failed to test. So it's like everybody points to this and says, "Ooh, you know, he's amazing. He's really done some amazing work, and it's fantastic." And it just really isn't. It's just one
Well,
of
they call themselves truth seekers, but in fact they have a medical condition that they are truth blind.
yeah, or logic blind. Yeah. I don't think
So
I don't think there's anything. I don't think there's such a thing as absolute truth. But I do think the preponderance of evidence they are blind to for some reason.
yeah, could be.
Mm.
So what about that moon issue with Dave Marsh?
Oh yeah, no. So what he's going to do is, so he was the one that passed me those sun pictures, and then he said, and then I went back to him and said, look, these, I'm really sorry, these absolutely do not show any angular size change in the two that I can see, and then the one that does show a difference in volume, it also shows the fact that it's maintained its width. It's just no longer a sphere, which is what I'd expect through compression through the atmosphere.
Yeah,
Not due to
that's
the
the sun.
length, not due to the amount of atmosphere, but more due to the angle of incidence that you're going through the atmosphere.
Yes.
So I said to Wright, because I'm in a Skype chat with him and Anthony Riley, and I said, look, I'm really sorry. No, I'm correct. There is no angular size change, and this evidence is not evidence for anything other than what I've said. And then I think in a typical flat Earth style, what about the moon? Blah blah blah. Straight onto something else, and I'm then like, whoa, no, let's just look at the sun first. But now that I've made that statement, and they've not kind of said, we disagree. Now it's just a case of he's going to go away and pass me some moon observations that will show angular size change. But the problem with that is, wait a minute, because I haven't really. I find this interesting because I've not really looked at it. So this is new to me. I've not actually looked at, how much would I expect the moon to change angular size based on stuff.
It does change all the time.
Yeah, but I also, in my thinking, I don't think it's going to do it consistently. So, without me looking, I've not looked into anything at the moment. Yeah, I've not even looked into the ecliptic plane as in relation to the sun. So I've not even got that far yet. So I've absolutely not looked at anything. But I'll share this with you in a second, because these were my thoughts, and you can let me know what you think.
Okay.
So my thoughts were, let me share my screen to you. Yeah, so my thoughts were as follows. You see, we've got the Earth here. Now, we've got the Moon, but its orbit path might be like this. Well, would be like this. Yeah?
Okay. Yeah.
But the problem with this is we've also got the Sun, which is over here. Now,
Yes.
I don't think, and because this is not, this doesn't do one revolution per day, the Moon, obviously.
It's the Earth. Yes.
Yeah, so I think this is actually going to go more like, or the orbit path around here is going to go more like this. Make sense?
That that does happen along the course of I think 18 years until it completes one cycle.
So how long between these petals here, though? So you're saying how long does it take to go all the way around it so that it forms a uniform shape again? So from here back to this point here, you're saying 18 years.
I think so, something like that.
So how long between this peak and this peak? And how many of
18.
these are there? This is something that I've not looked into, but in order to answer and evaluate angular size change, I'm going to need to look all this shit up.
I think 18 years, they are, you divide by the lunar month. So you can, I think so, those peaks. 18 by how much? Or multiply 18 by around 12, kind of, not exactly. So those would be the peaks. And then you divide that, you divide 360 by those, by the results.
So yeah, I hate math, and I wasn't actually paying attention to what you just said. So approximately how much in between these? And how many? That's yeah. So you're saying
yes. How many you divide? You multiply. No, I'm not sure.
Because you're saying these are 1 month cycles, yeah? So whatever the lunar month is. Wait a minute, we can work this out, or I can work this out. I hate math. Where's George? I don't even know how long a lunar month is.
27 days, 0.3.
So what we got? So we got 18 years times 365 divided by what did he say? 27 point what?
0.3.
27.3. Jesus. So in 18 years, there's 240 of,
Yes,
of these
so,
petals.
Yes, so divide 160. That's a full circle by 140. So that's the shift. On the background stars.
So wait a minute. Yeah. Okay. So it's only 1.5. So that's every 1.5 degrees then.
I think so.
Is this okay? See, that's less than I thought. I thought this would be greater. Because wait a minute. There's another. Is there not? Will these orbits not get changed by? So obviously we've got the Earth with a gravitational field. We've got the Moon with a gravitational field, but then we've got this huge ball of flaming mess over here, which is the Sun, with a huge gravitational field, which means surely these are actually affected. So if this was doing this orbit here, if it was here, maybe it might be more stretched at the peak, so the distance here is greater than the distance here because of the magnitude of this force.
Yes, I think that's that's even the direction of rotating orbit. It's counterclockwise.
So, God, I bet this is hard to work out, actually, isn't it?
Well, there's even more to that. I downloaded some PDF about the moon orbit. There was a lot of stuff. And you're just looking at the top view, and when you're looking 3D at this thing, it's more complicated. the moon right now on the orbit that you draw is at the farthest point, but it's not the highest point. So when the orbit rotates, it's not the same altitude.
Hmm.
It could be different altitude, but the same distance, but different altitude.
Oh, so wait a minute. So you're saying if we're looking side on and this is the Earth and the Sun is over here, when we're at, let's say, position A and B, when we're at position B, the altitude could be here, but then at position A, the altitude is actually here, even though the distances might be the same to the Sun, the Earth.
Yes. Can you draw the Earth and the Sun behind the Earth and side view of the orbit?
Oh, wait a minute.
Like,
I'm gonna save this as notes actually. So wait a minute. What we've got is 27.5 for a lunar month, 1.5 degrees for that lunar month is the offset, I guess. Yeah. So yeah, so yeah, so if we have the yeah, so we've got the Earth here. Wait
yes.
a minute, let me rub this out. No, let me rub this out. Yeah, so we have got. I'm sure George is having a lot of fun with that video. So yeah, so we've got the Earth here. We've got the Sun, which I'm going to draw like this because it's a bit huge.
Okay.
And then we've got the Moon here. But the Moon I can move wherever I want. So what you're actually saying is, during these cycles of 1.5 degrees, it's going to drop down. Because our ecliptic plane to the Moon, I believe, in relation to the Sun, is about like that. Are you saying that that
Yes.
isn't always the case? So this is what we'd expect, obviously. But are you saying that this actually changes? Because I didn't think this
yes.
did.
Yes, it changes.
Oh wow!
Not the total 5 degrees that does not change, but now the moon is on the highest point. Weeks later, this highest point is not the furthest point.
Oh right, yeah. Now I get you. Ah, so they're actually.
You know, it's like what? It's like when you're holding a balloon full of water and you're squeezing it, but then you you change the squeezing, so the balloon changed, but the water, I don't know how to describe it.
Is it no? You know when someone does a hula hoop thing?
Yeah, yes, it's like the hula hoop.
Yeah, when they're going it round. So that the actual orbit oops, wait a minute. The actual orbit itself, although might be that, and we might be here, as in the Earth. The next time it goes round, this might entirely shift, so that the Earth ends up here maybe, and we're kind of processing, or we're kind of we're moving in this range of it.
Not exactly. Looking top view, that 1.5 degrees is what you draw previously. But when the moon at the farthest point where we are measuring the 1.5 degrees, sometimes that place could be high above the Tropic of Cancer, and sometimes it could be below the Tropic of Cancer. Did you see the video that I posted on Skype?
Video that you posted. What, just now?
No, maybe yesterday. Just a 4-minute video using something like a Kerbal Space Program.
No, I did not, I'm afraid.
Okay, well,
I saw a
recommend you.
woman. I saw a woman with a violin, but that was it. And
No,
then
no, no, no.
which?
That's today, not mine.
All right. Which channel did you post it in?
Okay, let me check. Not the same one with the woman. I think maybe the other group. Yes, the other one. The notards. The missing. It's called the missing.
All right. Wait a minute. Let me have a look. Oh God, yeah. Now I can see it. I scrolled straight past that because it had a black background. That's
It's what?
it's the video. You know the thumbnail in Skype. My Skype is on dark mode, and the video's got a black background. So I just breezed straight past it without actually realizing it was a video. Right. Yes. Oh crap! Is this going to show me the fucking orbits of the? Oh, is this you playing about with it, by the way? Oh, yeah, it is. Nice. Do you know? Right, okay. Do you know what you should get? You should get Blender.
Ah, I didn't.
Yeah, but is it? Yeah, but have you got it recently? Because the latest, get the beta version of the latest version because it is entirely different. It's usable. They've redesigned it completely. Every other version, other than the latest beta, which is not out yet, but you can download the beta, every other single version from me, a professional, I say it's shit. This latest version, I am in awe of. It's pretty stunning.
It could be easier for you more than the other versions, but for me, I don't think I can go through this again. It's very frustrating.
So our ecliptic plane is only 5 degrees offset to the sun.
Yeah.
Oh
Almost.
well, I thought it was a lot more than that, to be honest.
No, only 5 point something.
Wow.
But you know, there's other factors that can make the moon bigger and smaller. Like I think even between the what do you call it? The noon time of the moon or the zenith. You are closer to the moon by 6,000 kilometers. So I think even this can.
Yeah, but I mean, if you go on that, that is, you know, for the moon, I need to work out the tolerances. So obviously, wherever the Earth sits here, and whatever the distances are, minimum and maximum, that's the angular size change that I need to disregard. But that's, you know, at 250,000 miles. If we're only on about 5,000 miles, whether we're closer or further away, that's what, still only 2%. 2% size change then is what I would expect here.
It depends on the time span he's making between the two images.
No, but I mean, I'm always going to go off a maximum. So the closest we can be versus the furthest away, I would expect a 2% change in angular size. So if it's more than that by a fair degree, yeah. So I'd say 2% to, I don't know, 4% for pixel tolerances.
It's gonna be more than that. I think that the moon grows a lot because it's somewhere between in kilometers, 340 and 380.
Wait a minute. Sorry, say again. So the moon is 250,000 miles away, maximum, isn't it? Or 256, I think it is, or something.
I'm not sure. I'm on time and date now, and it has the distances.
Oh, does it?
Yeah. So I can check the nearest pass and the furthest pass just right now.
Yeah.
So arrow. Okay, so 386. That's the maximum.
Kilometers now, aren't we?
No. Wait. 404 kilometers.
Oh, wow, okay.
And the minimum can go down to 360.
Holy shit. Really?
Yeah,
Wow. I did not think that it was that much.
that would be 14 days between each one. Around 14 days or 20 days.
Holy shit. So now I'm looking at a 10% change in angular size. That's a lot.
Yeah.
So I would actually say the tolerance versus atmospherics and stuff is anywhere up to, let's say, Jesus, probably about 14%. Anything that is over 14% I'd consider anomalous.
Yes.
and interesting. But if it's under 14%, then yeah, no. But I did not think these were the two. These were the two. These were the distances. Wow.
Yeah, that orbit is freak.
Because it's 9.1% actually difference. So.
By the way, this distance, like when I say the maximum is 404. In some other months, it could be 406.
Yeah.
So even the distance itself changes for the peak. The peak of the distance changes.
Wait a minute. So this is 368,000 kilometers, but as well, shit, you have to also account for observer position then, because the distance between here. So if we've got the Earth here and our observation point is here, and we're rotating round, in the same view of all of this, there's actually quite a large distance between here. What's that?
6,
That's yeah. Well, you think that's that's probably 6,000 kilometers, isn't it?
Yes. So divide that by the 404.
Yeah. So, oh shit, Jesus Christ. So 404 times 100. So we're actually looking at a 1.5% difference here. So I'm going to have to raise this to 15.5 then. Just to make sure. Now anything outside of that range.
So you have two ratios. The first ratio is fixed. That's for the noon and the zenith and the setting or the rising of the moon. This is the 6,000. This is constant. You have to divide it by the distance. The distance itself, you can get it from time and date. Or actually, there's a better site that I would share with you. It gives you the distance on a specific hour, not just the zenith of the moon.
Yeah. Well, I think I'm all right now to actually say, if it gives me the images. Now that I've got this, I know that if there is anything over 15.5% difference in angular size, then I've got issues.
You Dean?
Hey, oh George, you've had that were longer than 10 minutes, mate.
Oh, hang on. Forgot to turn the audio back up for you.
Are you slacking, George?
Where is it? Okay, Dean?
So, yeah, can you hear me, George?
Am I interrupting anything?
No, it's all right. We're just working out tolerances of angular size change of the moon, which I needed to get straight in my head.
Oh, you mean from high noon to sunset?
No, through the phases of the 27.5 lunar months versus on the entire 18-year cycle of the.
Well, never mind.
Yeah, there you go.
Sorry, I asked.
So anyway, yes. So that was longer than 10 minutes,
well, tell me
George.
what is your consulting rate? How much am I in for now?
No. It's all right. Let's just even it out by sharing information freely. How's that?
Well, that's where I was
I
headed.
know it was.
Because my consulting rate was going to be higher than yours and more time. See?
Yes, I know. That's why I would have never given it first.
This will be like grapes of wrath. You're always going to owe me.
Yeah. So, but it
on
took
that
longer than
video,
10 minutes. Took longer than 10 minutes, mate.
Yeah, I got a phone call, and plus I was trying to decipher some of what he was doing. Now, his math is horrendous for one thing. Why anyone would use a 0 or an O for a variable ought to have his head examined, for one thing. Is for observer, he uses O, and it's just messing with my mind because that's always 0 in my mind. If he's going to talk about observer height, he should have called it H sub 0 or H sub 1, H2 instead of 0. God.
So once you get over your disgust, then what was your proper evaluation of it?
Okay, 2 things here. Let me bring the video up. I don't know if I really need to examine the rest of the video in detail. After what I tell you, you'll have to tell me, and then I'll go more into it if I need to. For one thing, is his math is off a bit. I don't know if it really makes a hell of a whole lot of difference, but 0.02 degrees is not 1 arc second. 0.02 degrees is 0.01667 arc seconds, so all his math is off by about 17 cents. So instead of 300, what was it, 57.6 feet, he should have actually had 455. But neither here nor there. One of the obvious problems that I found is, can you bring his video up for yourself?
Yeah, give me a sec. I think I've already got it. Well, which one were we looking at? We're looking at diffraction limit example, weren't we?
Right, yeah. Go to time 3 minutes, 29 seconds.
Give me a second.
Another thing I found was really disturbing is him having his camera rotated 90 degrees and continually flipping things around. I don't know why he did that. But.
Well, people think there's an up and a down, don't they, that's magical in optics for some reason.
No, if you go like 324, he's got everything. Yeah. The floor is vertical rather than horizontal.
Yeah.
I found that annoying. But anyway, at 328, 329, where he's got it oriented properly. Now, if you slow it down to 1/8 time, go to the settings wheel and put your playback speed down to an 1/8.02 or 0.25 or quarter speed. I mean.
We're going to say your math needs checking there, George. I'm really sorry.
But anyway, if you play about from 329 to about 347 or so, where he's flipping back and forth, going up and down, you can see obvious unevenness in the floor, and things actually jump. And you can see how reflections off the floor are interacting with the light to wash it out in some points. But if you look in the hallway there, like on the right-hand side where you have, I don't know, what is that? Is that doors or something there on the right hand?
I think it's I think this is a hospital or something.
There seems to be a dip in the floor going across at that point, because as you play this back slowly, you can see something rather dramatically happen. It jumps as the video, as your light rays start passing through that area. And it's not continuous. Like I say, things jump because of the unevenness in the floor.
Indeed. So is that the only thing that you is that your only criticism of it? The flaws uneven?
Well, that's a big criticism because it kind of invalidates everything. The way things jump around and the way that the light is merging off the floor and interacting with the direct light, I find that a huge problem.
Hmm. And what is there anything else?
Like I say, you mean in the video portion or in
Well,
his?
just in his thought process and how he's working it out, and
No,
the
I didn't
test.
really pay much. Well, once I started seeing this, I just said I'm not going to bother with his analysis because, like I said, I wanted to bring this to your attention first, and if you feel I need to look into his analysis further, then I'll do that.
Well, click on my sharey screen thing.
Yeah. Okay.
You got a white canvas up.
Right. Yeah.
Right. So, what two apparatus does he use for testing this?
The phone and a camera.
So
and that's another thing I wanted to bring up to you is about lens sizes.
Oh, right. Here we go. So now we've got a tiny little lens size and a huge lens size, of which he specifically has a center line for, and says these are centered. And as you were probably about to point out, what happens when we get a light ray that is coming in at this?
Exactly.
One camera sees it,
Exactly.
one fucking doesn't. Yeah. It's that simple.
In fact, that's something I wanted to talk to you about. I brought this up to Rumpus about a month and a half, 2 months ago. And we never finished our discussion on it because he had no answer for it, and we were both going to think about it a little more. I want to get into this because this is a very interesting thing that has bothered me for years, and maybe with your optics background that
I don't have an optics background. I just happen to know how a lens works. It's not that I've got an optics background.
That's good enough.
Yeah.
That's more than where I'm at on a lot of this stuff.
Yeah.
I'm no optics expert on the use of cameras, and I don't have much experience with, playing with lenses and things like that. All I know is, I can analyze things mathematically or think about things, but sometimes there's issues that you haven't taken into consideration.
Well, here's another issue. Here's another issue. So the actual the last lens element, which is which is the first refraction control element of the lens, is not going to, on the DSLR and the huge lens, you're going to see a shitload more than, especially on a direction source where you're only expecting to see it in a certain direction. Obviously, that's going to play a big part of it. But then there's another problem. And the other problem is that DSLR you have got fixed control of. That's why you would get a digital single lens reflex camera for. It's a professional grade camera that you can expose it how you want. You can control the iris, the shutter speed and the iris aperture opening. You can fix the focal length. You can manually focus the damn thing. All of these things. Now the problem that you've got on an iPhone is it does automatic gain digital ISO.
Right. Yeah.
It does autofocus without your control constantly. On an iPhone, I think it might be a 9 point or even 13 point autofocus.
Yeah.
And an auto.
No, I did know that.
Yeah. No. So you did know this, did you?
Yes.
Yeah, because the autofocus.
No, I do have a question for you.
Yeah, go for it.
The difference between a fast shitter and a slow shitter, is that how quickly it flushes?
Yeah, so what actually happens here, so it's based on fractions of a second.
No, yeah, you missed the joke.
Oh, right. No, yeah. Now, when's it?
A fast shitter. We call it John a shitter sometimes.
Yeah. Do you know how single lens reflex cameras work? Although everything's mirrorless now, actually, which is a bit weird.
Not really, no.
So you've got an observer eyepiece here that comes in. You've got a sensor here. And you've got your lens elements here, where light's coming in this way. And this flips out the way. So when light's coming in here, you're looking, it's called TTL through the lens, because your eyepiece is looking directly on what the lens sees. But when you press your finger,
that thing flips.
Yep.
Okay.
Flips
Cool.
up there
All right.
and exposes the sensor for a
Okay.
1/200th of a second.
Yeah. So you never really notice that flipping up.
Yeah. No. But that's the thing. You control this number on a DSLR, the exposure time.
Right. Right.
Whereas on an iPhone, you fucking don't. It decides. And it decides it decides auto leveling, auto gain, or digital ISO from the sensor, as well as focus points, all automatically based on what's on screen. So
and that's all determined by some algorithm that they have built into the camera.
Absolutely. So by having the field of view looking at this, so this is the field of view down to the floor, versus having the field of view, this is a side-on view, by the way, versus having the field of view with the camera so that it's looking like this. You've got autofocus points now that are further along. You've got auto leveling points that are evaluated that are further along. So it's going to subtly and or sometimes quite dramatically change how the sensor is going to interpret the image. So you are going to get things bouncing in and out. It's going to change contrast levels. The amount of shit that goes on in there, in that digital processing unit, is ridiculous.
So what you're saying, what I'm seeing as the light reflects off the uneven floor, the camera is adjusting itself.
Yeah. Oh, no, the camera's 100% always adjusting itself. I couldn't even tell you that that's an uneven floor. All I can tell you that what you might perceive as an uneven floor is the way that the focal points are shifting on the lens, and the sample points are altering the digital correction that the image processor is doing. There's way too much there.
Yeah, obviously, as he's moving up and down, you have light being reflected off the floor to the camera from different distances.
Yeah, and I mean, if you think about it, if it's doing the digital ISO gain on the sensor itself, when you're picking that up away from the surface, it can actually, if the ground close to it was perceived, the luminance values were quite high, and then you pick it up and looking down, if those drop on average given the sample points, it's going to slightly boost the ISO, which might just be enough to burst that light into view. But then the other thing that you've got is on an imaging sensor, well, you know this, on an imaging sensor, there's no such thing as subsamples. So if an object is, let's do this. If an object is here like this will be a good example. So if an object is here like this, and the light from this object, this is what this is seeing, and this is actually the imaging sensor and the receptors with, a standard CMOS sensor. If it's here, it might actually not be visible at all, depending on how the DSP has been told to interpret the image via curves and interpret the sensor data via curves and things. It absolutely would be visible there. So you could actually have an object that is out based on all of these things, go all the way down here and not be visible. But then if you go up, you can have it come up here, and now it'd suddenly burst into visibility here.
Sure.
And then it'd be really visible here and really in your face. So there's all these elements that I don't know whether, he claims to be a professional. I don't know whether is not very intelligent, is mistaken, or whether he's purposefully deceitful. But he doesn't mention any of these things, and these are things that you have to rule out.
Well, my guess is he's not a professional, because I found more often than not these flat earthers always tend to over exaggerate their credentials and their experience. I mean, i.e., case in point, Bob Noble, to the point of lying about the credentials that he does have. And what about that guy? Remember that guy Cullen in the Hangouts there, in Jose's Hangouts, is telling us that he's got a degree in geology and stuff. I mean, and he's studied these things, astronomy, for 20 years. He didn't know anything. I mean, I don't believe him one bit what he told me about having degrees and the experience. He didn't know the terminology. He told us he had a minor in climate change in that, and he didn't even know the major players in the field.
Yeah.
I mean, yeah, you can't study these things for 20 years and at least haven't come across a few names who are the prominent experts in the field on both sides.
Yeah. I'm a bit angry with Chris Berry at the moment. I want to.
Yeah.
I want
Well,
to.
hang on. Hold that thought a minute. I need to make a quick stop over at the library and get myself a drink on the way back. Hang on.
Yes.
I gave you some slightly wrong information about the change. It's not 18 years. It's 8.5.
Khaled, all my maths on the previous thing were based off that. Are you saying? Right. Okay. Actually, that. Wait a minute. Okay. Let me.
It would like double the value, something like that.
Oh, so it's like 3 degrees.
Yeah.
Okay.
3 degrees every what? Every month?
Yeah, 3 degrees every lunar month. 27.3. Yeah, 27.3 days.
Yeah, but there's something else that has a cycle of 18 years, and yeah, it's called the line of nodes.
What the is this something that I'm gonna have to learn as well?
Yeah, and I have to open my laptop for that.
Jesus Christ! Wait a minute. Is it gonna alter my 15-degree tolerance? It isn't, is it? We've already got that.
No.
Yeah,
No,
yeah.
it's all about the distance, and the distance, just as I told you.
Yeah, none of this is. It will just make it so that I could predict where it's going to be easier, or explain its motion easier.
No, it just it might come handy on some other subjects. So I'll share my screen and I'll show you again my 3D paint.
You see, the thing is, you've done some quite decent stuff in 3D paint, and you're scared of Blender. That's a bit weird.
Of course, 3D paint is very easy. Blender is so complicated.
No, Blender was hard. It's not anymore.
Well, maybe I'm back.
Wait a minute, George. We're just having a look at something. I'm still working out this moon stuff because this Dave Mash is going to pass me some moon images to evaluate soon.
Can't you see my screen?
Yep.
So you see this is the Earth.
Yep.
This is the
normal vector of the Earth. Yeah. Oh, rotational axis. Yep. Or it better be.
Yeah. No, I think you should forget about this.
Okay.
Yeah. It's the axis of rotation of the moon's orbit.
Oh, so the ecliptic, yeah. So the normal of the ecliptic, yeah.
Yeah. So this is the ecliptic, and here's the moon orbit. This is the direction of movement.
Yep.
This is the apogee. This is the perigee.
Yep.
And this is the highest point, and this is the lowest point. So, and this is the line of nodes. This black bar. That's when the moon is here on this line, the sun on the other side of this line, then this is an eclipse.
Right, okay.
So this orbit, this red triangle here, it goes to the left every 8.5 years, something like that. And this black bar, or the line of nodes, it goes in the opposite direction every 18 years.
These are called the Soros cycles.
I think so, or one of them called Draconese or Draconian cycle, and the other is called what did you say?
Soros, S-O-R-O-S.
Yeah.
There's several Soros cycles. One is at 18 years. I forgot the other one. They're 20-some years, 26, something like that.
Yeah, there's more. There's one that is 8, and in fact, I think there are 4 or 5
The whole
cycles.
collection is generally called the Soros cycles.
Oh, yeah, okay.
So you're into
But if
astronomy
you,
as well, George?
Pardon?
You're into astronomy as well?
Yeah, I used to teach at the college level.
No, nice.
oh my God. Oh.
So I've got a question for you, George. This
Oh,
will be
sorrow. I'm sorry. Yeah, go ahead.
no. This will be interesting for you. I'll share my screen.
Yeah, here we go. The Saros cycle, SAROS, the periodicity and recurrence of eclipses is governed by the Saros cycle, a period of approximately 6,800 or 585.3 days, 18 years, 11 days, 8 hours. It was known to the uh, Chaldeans as a period when lunar eclipses seem to repeat themselves, but the cycle is applicable to solar eclipses as well.
Right, here's a brilliant thing for you, George and Khaled. Because Khaled, don't answer if you were actually on the Hangout. But I was showing this, and this is why I want.
Are we on now?
Just click
your
on.
icon?
Yeah,
Okay.
click on me.
Okay.
So I was showing this on Sean G's show, yeah.
Mm-hmm.
And what I said is, what we'll do is we'll plant, and this is now in Florida. This field of view of this camera is in Florida, and this is what we would expect on a flat Earth, yeah. Now, what I said live on the show was, hey, the sun never gets the horizon in this reality. Now, Chris Berry piped up. Well, first of all, I noticed that he said something in the side chat. Dean is being very dishonest right now. And I was a little bit puzzled as to what I might be being dishonest with.
Mm-hmm.
So he was saying something in the chat, so I had to say, oh, everybody, wait. And then Chris just managed to get to ask me something, and it was, Dean, does your model have atmosphere in it? And I'm there like, well, what? Why would it? This is geometry. It goes,
yeah.
but wait a minute. It goes, does it have atmosphere? And I'm there like, well, no, it doesn't. It goes, right, that's it, thank you. It doesn't represent reality then. Now, but wait a minute. What do you think he was wanting me to model into this? My guess would be refraction.
Yeah, exactly.
Right. So what's the problem with that, George? Not the fact that I can't do it, but what's the result of that?
Well, the refraction is going to make the Earth look even flatter than it really is.
Well, it's going to
move things upward.
Yeah, it's going to move the sun further away. So it's right. Like, why are you arguing for something that will move it further away from the horizon? It was so. Exactly. I want to get him in a hangout and say, I can actually put refraction in there. I could just put inside of this now. I could put a solid element with a refractive index. Brilliant. What do you think it's going to do, Chris? It's going to move the fucking sun up.
Well, that's always puzzled me about these flat earthers is have they realized that, on normal atmospheric conditions, you tend to have denser air near the surface of the Earth. So it tends to raise objects a distance up. So it's actually going to make the curve of the Earth, it's going to flatten it out in a sense. It's going to make it even look flatter. So why would you want to introduce refraction into a spherical Earth observation?
Oh, wait a minute, George, you've just wait a minute. So in time, wait a minute, on distance then, of course it would. I'm just thinking, what would a flat disk look like? It wouldn't actually look like this with refraction. It would appear to kind of bend up the further away that you get, wouldn't it?
Yes.
And then fade into nothingness. So not only would it move this up, it would also, I'd see, I'd have things in the distance on this flat plane bending slightly higher than where the geometry horizon line should be. Huh. Wow, yeah, this would look well different.
The what was I going to say here? One thing I was going to talk about when we first saw this about an hour ago. That somehow, oh yeah, I got a phone call, and that's what distracted me. Now, if you take a flashlight and say you have a friend with a flashlight out in the distance, and he's shining it off to the side, say perpendicular from the line that is between you two, and so the beam is mainly focused out at right angles to the path distance from you and your friend. You're still going to see the flashlight there because there is residual light. You don't totally block out all the light.
Mm.
And on this flat Earth model, what has always disturbed me about the sun going around, unless the sun had a very opaque lampshade to focus the light downward, anybody on the Earth is going to see the sun.
Oh no, absolutely. But I mean, the the fall off of the light is, it's never going to go away. Well, you'd always be able to see the shape of the sun, even if the light didn't actually make that much of a difference to your area.
At midnight. Yeah, at mid. Stop it right there. Stop it. So the people here in South America, say in Chile or whatever, are at midnight. They're still going to see the sun, unless it had some sort of a lampshade over it.
But wait a minute, George. That's brilliant. But the sun is actually, is this big ball of burning, well, big plasma ball. But have a look at the moon. Think about the observations of the moon if it was actually local, because we see a deviation of 5 degrees. Yeah, we see a deviation of 5 degrees.
Everybody's going to see something a little bit different according to their position. Sure.
Yeah. So this is interesting by itself. The fact that this. I mean, we see this side of it.
In reality, we do have that sort of effect, but it's very minimal.
Yeah, 5 degrees. Yeah, we see
5 degrees.
Yeah, 5 degrees. I think. Yeah. But someone in South America now would be looking at this side and they'd see the dark side of the moon. Actually, wait a minute. Yeah, if you're in Argentina, Jesus, you can see completely the
reverse. It'd be a new moon in Argentina.
Yeah, wow.
Whereas the people on the other side will be seeing a full moon.
Yeah. See, I need a flat Earth expert on this that can tell me how this works, and I'll model it, I'll animate it, I'll do anything.
The phases of the moon will be position dependent on where you are on the surface of the Earth. You'll see everybody at any given day, depending upon where you're on the Earth, would see a different phase, right?
What about if these... Oh, no, that'd be worse. I was going to say, what about if... With the moon, you can have it really high, but the second you move the orbits of these two things up, then everybody sees them all the time, and they just circle around in a...
But I mean, just... Okay, no, bring it back to where you were. Keep going, keep going, keep going, keep going, keep going. Rotate, keep rotating. Counterclockwise. Keep going.
Give me a degrees.
Okay, right there. That's fine. Now, to someone up around, let's see, a little bit south of Greenland there, they're going to be seeing a full moon.
Wait a minute, George. We're on a flat Earth, and south, I've got 360 degrees of south from Greenland, which...
Yeah, but I'm saying south of Greenland.
Anywhere south. Okay.
No, up to Greenland.
Yeah, this is Greenland.
No, it isn't.
Yes.
Greenland's the white spot up there near the north. Greenland. There's Greenland.
Oh, no, my mouse, when it's shared, doesn't actually appear where it's supposed to be.
Oh, okay.
Yeah. So,
anyway.
Greenland is here, yeah.
Yeah, right. Yeah, keep your red there. Oops, okay. Well, back away now so we see the moon. Okay. Now, going in line, like on the peninsula sticking out there on Greenland towards the moon, if someone's standing on the end of that peninsula, they're going to see a full moon, essentially, right?
Yeah, yeah.
Moon is almost, that person almost be in line with the moon and the sun. So the moon's going
Oh,
to be fully illuminated,
this
right?
is why they say the moon's got to be a luminary, isn't it? Because otherwise, this shit just really doesn't work at all. Well,
No.
it's an obvious
Well,
fallacy
well,
then.
we'll do the get up higher a little like we were.
Wait a,
I just want.
wait a minute, give me 2 seconds, because I'm just going to turn this off and actually lighting, use all lights, and yeah, and I'm just going to make it, because that's a good point, the different phases of this thing. So if I kill the ambient color, now I've got a moon that actually does, you know, if it's been illuminated by the sun, we're fucked.
Exactly.
'Cause, yeah.
Exactly. Yeah. Depending upon where you are on the surface of the Earth, you're going to see a different phase of the moon.
Yeah. So like here in Mexico.
Yeah, you got a quarter moon now.
Yeah. Whereas in Florida.
Or half moon.
Yeah. Whereas in
Now you almost a
Florida.
full moon.
Yeah. Jesus.
So you don't have to wait through a whole month to catch the phase. Just move around the Earth at any given day.
Yeah. So that. Yeah. So, yeah. I'm never going to be able to get this to work. I really am not. Not even with my ability to be God inside of this damn program.
Yeah, that's what I'm saying. I just don't think, I can't see a transformation possible. No matter how you fiddle things, that isn't give you what you want. You might get close, but you're never going to get there.
Did you consider the dome being like double the size of the flat Earth, and the sun, the moon are actually below the Earth, and we see their reflection on the mirror dome?
Go away, Khaled.
Wait a minute. Let me think. Yeah. The problem that I've got with maybe that's a fair.
Well, the sun and the moon are going to have to be outside the perimeter of the flat Earth in order for that to work, right? Otherwise, the disk of the Earth is going to completely block out the light rays.
And no, I was saying like maybe not exactly under the disk, but sideways somehow.
Well, you'd still have to be outside the perimeter.
Yeah.
Yeah. Well,
Well, that's contradictory because sun and moon have to be enclosed within the dome.
No, I like what Callan's saying at the moment, but yeah, the problem is, even if I make this, an incredibly shiny, transparent dome.
But you can't have anything outside the dome because that's water out there.
Yeah, but what?
Oh yes, I forgot.
Yeah, but what Callan's saying, this wouldn't be outside of the dome; it would still be inside, George.
So now it's a spherical dome.
Yeah. Well, no, yeah. So basically, we're actually in here like this with it all.
Yeah, but the dome actually intersects the Earth somewhat beyond the ice wall.
Wait a minute. Have you seen it, or is that a speculation, George?
Oh, that's a fact given to me by the flat earthers.
Is it? Not all flat earthers have the same opinion, though, do they?
Well, that's what makes it such a moving target.
So I have a project right now. It's a very tricky project. What if you made a video saying that this model of the flat Earth will explain the sunset, sunrise, and everything, and don't give any details, and put this video and see how flat earthers will jump on it?
Yeah, so I'm actually just playing with your where's my eccentricity now? I'm on a Fong shader. Let's have a blend. So I'm actually playing with your idea now, Khaled, and the issue that I've got is this reflection based on the dome won't work, because if I move the sun, which is this little bastard, it doesn't matter where I put this piece of shit, it ain't gonna produce what I want, because it's a dome basically. So you can see that, yeah, so I can, yeah, so even if this is what we're looking at now is the reflection on the dome, there is nowhere that I can put this, if this is a dome, that would cause a reflection on you know, the ceiling of this dome to make it look like this. It's just the angles don't work. Not
That's
even
right.
if I make this of a higher magnitude, or I suppose if I bring it right
it's never going to get reflected down to the surface.
Yeah, no. Well, it's not
At
just that.
least
I
we
can't.
tried.
Yeah, well, yeah, I can't get this. So the normal of this single face here pointing down, there is no real angle. There's only one angle that might show me that it's that high.
Yeah.
And it's going to cause very odd effects, like we can see here.
Well, the problem is also when it hits the dome, the fact that
It's not. Yeah, it's not going to be a circle.
It's going to get diffused outward.
Well, yeah, no, the problem is, as well, if it is a dome, that's the fact that it's a circle straight out the window, and we'd be able to see it, you know, we'd be able to see it geometrically change shape based on our angle of incidence as it's moving around.
Right.
Yeah.
But again, my objection, the two big objections, is one, regarding the moon, you'd be able to see different phases.
Yeah.
Depending upon your location on the Earth, and then on the one on the sun, is you would see the sun anywhere on the Earth, even of night, somewhere else on the surface of the Earth, unless you had some sort of a hood over the sun that would keep you from seeing the light coming in your direction from the sun. I mean,
yeah, but we can't then, because then the moon doesn't get illuminated.
That's right. And not only that, that hood would have to be going down almost close to the surface of the Earth, because with that sun being 3,000 miles up, even if the hood, say if the hood or the lampshade came down to the bottom of the sun, you'd still be able to see the sun because of your angle from the surface of the Earth peering upward at the sun. You'd be looking up under the lampshade. So it just doesn't work.
Yeah, I'm not wanting problems, George. I'm wanting solutions. How can we make this flat Earth shit work?
You know, the reason I came up with this mirror dome is for any observer, the distance will change of the sun, and that's
well, the only way it's going to work is all of us have to have our own personal sun. There has to be a billions of suns up there.
Yeah, but that doesn't. Yeah, but the problem with that, George, is we know it's a uniform sun because we can measure the effects of that sun that manifest uniformly, irrespective of us or our position or our observations.
Well, I had a flat earther once tell me that the atmosphere behaves as if there is a fiber optic connection between our eye and the sun. So we each see our own personal sun that way.
Nice. All you needed to do is ask him, do we each see personal shadow direction as well?
Exactly.
That's it. Case closed. That's the problem why I'm not entertaining that. Whatever I entertain has to be... It doesn't matter whether it can't be impossible. It has to be plausible.
Yeah. So, and of course, all these explanations that you get are invoking magic in some shape or form. You know, they don't think beyond the surface of things. You know, like the obvious problems or the self-contradictory nature of these explanations that they tend to have. A lot of times they'll come out with an explanation that explains B, but forget and not look at how A is affected, and it might break point A, and there's a lot of these explanations that they come up with that don't universally hold to be consistent with all the other points that they use for explaining. Point A might break B, and point C might break A, and it's just us. But getting back to our guy on the diffraction limit, I really do implore you to really watch that segment, 10-second segment from 327, say, to 427 in slow motion.
Wait a minute. Again, I'm gonna have to pull you up on math there, George. That 10-second segment from what to what?
Oh, I'm sorry. Yeah. 327 to 337.
I was going to say, your math just is confusing me now, George, and this is one thing that I would expect you to be well better at.
I've been around these flat earthers for too long. It's really starting to mess up my mind.
Well, I got this on record anyway, so I'm happy.
You bring it up, I'm going to bring up that incident you had back in the park there at Hyde Park here a while back.
What was that?
Well, I'll make shit up.
I got that on video as well, mate. There we
go. Anyway, watch that thing, and maybe you can explain to me why some other explanation besides the floor being uneven. I perceive it as being uneven. Of course, some of these other things about adjustments due to...
Well, first of all, no, I know... wait a minute. I know which one that you're on about. And just imagine... you see, when that light blends into reflections of the floor or high luminance of the floor, the camera will auto-level it so that it isn't due to Rayleigh criterion or anything, but the camera will level it and expose it based on the whole picture. So you might just merge into it for a moment. Yeah. So
look at time 3:30 to 3:31 and see how things jump, and see if you can tell me what's going on there. Put it in full motion at time 3:30. Probably if there was a finer time counter, it'd be like 3:31 and a half to 3:32, or I mean 3:30 and a half to 3:31, like about a half second there. The tail end of 3:30 going into 3:31, there's a jump there. I wish I could slow it down even more to figure out what's going on.
Yeah, you can't. Yeah,
but you can.
Oh no! You mean the distortion?
No, there's actually a jump occurring.
Well, yeah, it's impacting the floor.
Yeah.
Yeah. You're on about when it impacts the floor, right?
Well, hang on a sec. Let me look at this again.
He actually puts it down. He puts it back down on something. So he's going down at a free kind of angle.
Well, I don't know if that's when it impacts the floor or not, because it's continuous right after that jump. Look at 3:30 to 3:31, that 1 second.
Yeah, that's just angular change. I think his elevation is put it down on something, and that's why it immediately jumped. It's actually one of the worst iPhone cameras in existence as well. I think it's an iPhone 6.
Uh-huh.
So it's like, if you wanted to screw this up the most, that's...
Well, I don't know. There's actually like a frame change or something going on there. There's something happened there. And I don't think it's because it's impacted anything. Just...
Oh, well, wait a minute. Yeah, let's have a look.
You see the light as he's lowering it at 330, and then this jump occurs. Getting low. Bam.
Yeah, but he lifts it straight back up afterwards, and then when he puts it back down again, he puts it back down, less.
I don't know if you're seeing what I'm seeing.
I don't think
here.
there's anything sinister there. I think it's... But
No, I'm not claiming he's purposely doing anything. I'm just saying the way that the light is interacting with this uneven floor or something could be going on here. I'm not saying he's purposely trying to do something.
Yeah.
And plus, even after that, you start going at 332, 333, 334. You can see the light at the end of the hall distorting, getting elongated, then shrinks back down. There's a lot of light interaction going on here.
Yeah.
At 334, see how the light gets stretched out and then jumps back to flashlight size. I mean, that's telling me that the floor is really uneven.
Well, actually, there's a really good example of what I was on about at 333. Oh, that's that's nice. But yeah, 331 to 334. If you actually have a look at the lights at the top on the roof.
Exactly, how they're reflecting. Yes.
Well, that's not reflecting. They're actual lights. But if you step through like frame by frame, you can see that they are bigger than smaller, bigger than smaller, and that's the exposure compensation and the interpolation of the sensor crossing pixel boundaries and saying yes they're there, no they're not, yes they're there, no they're not, because this kind of camera is very pastely. It kind of it crushes all colors.
Could some of this be happening by an interaction of the sampling rate on the phone interacting with the 60 hertz of the fluorescent lights?
No, because the camera.
Yeah, you see an awful lot of flickering going on with these lights. Yes. At the ceiling, if you watch it at the ceiling.
Well, yeah, not just that. Everything is synchronized on the phone to 60 hertz anyway. So the screen is 60 hertz.
What I'm
the
saying
sensor
is
sample rate. Yeah, but the sensor sample rate. All sensors on an iPhone are 60 hertz.
Forget about that. I mean, the fact that you say to focus at the ceiling, yes, you can see an awful lot of crap going on there. Adjustments.
Yeah, it's just ridiculous. It's just a ridiculous test, this, George. I mean, look at the difference in the images from the DSLR versus the iPhone.
Know who you have to thank for this?
Oh my God, I don't want to know.
Probably Jose. He's the first one that came out with when he was at the supermarket in a flat earther. He was the first one to do this, if I recall.
What a bastard.
Yeah. So you should rib him about that.
Yeah, you see, the problem that I've got is this floor does look pretty flat from the DSLR standpoint, but that's because you've got a wider lens element. You've got a more surface area to capture light on, and a higher kind of lens aperture to capture the light.
Which one is the DS?
The white, so you'll see more natural colors. The
no,
iPhone.
I'm saying at what point in the video we're doing that?
Oh right, so I'm at 348.
348.
Yeah, versus 344. Okay. 348 versus 344. If you blink, if you blink test between them.
Yeah, I'm gonna look at it here.
Yes. But Jesus Christ, even the. So, what is this camera? Wait a minute. So you've got a DSLR, a 70D. Wait a minute. This is terrible.
Wait, I don't see anything happening with the light going away.
Oh no, on the 70D it won't,
Okay.
because
So, okay, so what's he trying to demonstrate in all this?
that things can disappear based on aperture and diffraction.
But if people are using a real camera rather than a iPhone or
Well, yeah,
smartphone.
yeah. I mean, the issue that you've got, the bigger issue out of all of this again is ridiculous. So you know that diagram that I did a little bit back where we've got that
Yeah,
pinpoint that just matches a pixel.
right.
Well, that pixel there that was jumping in and out on that demonstration would have been the iPhone 6 at 12 megapixels.
Hmm.
Whereas imagine all those a much tighter grid, because the actual DSLR that is using is 20 megapixels
Right.
and high quality. So yes, something that small is and is more zoomed in as well. So something like that is never going to go out because there's actually 4 pixels to fucking represent it on the
Hmm.
DSLR, but there's always less than 1 on the iPhone. It's absolute. This entire test just screams.
Yeah, he doesn't understand at all what he's doing.
Yeah. And
So the question is, I mean, how is this supporting the argument of things disappearing at the bottom up? And clearly, you're seeing that the light does not disappear with the better camera.
hmm, hmm. And yeah, it's all those things. It's the center of the lenses as well, being at 40.5 millimeter height, which is fine, except one of those lenses ends at 60 millimeters high. The other ends at 41.5. So
Yeah.
go figure that shit out.
You can, you know, tell him first off, he
It's
should do it.
yeah,
Do
14%
use
out or something. Is it
yeah,
17% out?
14%, yeah,
Yeah,
17% error. You can't
that's,
even do uh, um,
well, it was converting
conversion.
degrees, yeah, to arc seconds.
Right. Yeah.
Yeah.
One arc's um, 0.02 degrees is or
Oh, be careful,
I'm
George. You're
saying
being recorded.
one arc second is 0.01666 degrees.
Yeah.
It's one arc second is one. Were we at 1 arc second? No. Oh, I can't even remember. Forget it.
iPhone 6s. Yeah, you cannot. I mean, what you have is you have so when you're testing like a camera lens or a camera sensor and its performance, you do contrast, color, and you shoot detail sheets as well that are varying distance of gaps between very high contrast lines, so that you can test. You can test how you can
Sure.
actually, if the sensor is really high quality, you can test that the diffraction of light coming in is a limitation of either the sensor or the lens in the way that it can perceive detail. You don't, to compare a DSLR with that level of glass against a shitty iPhone is about the most ridiculous thing that I've ever seen.
Yeah. I'm sorry. We're talking arc minutes. 0.02 degrees is not 1 arc minute. 0.02 degrees would be 50 seconds in a minute, not 60 seconds in a minute.
Hmm.
So 0.02 degrees would be, or 1 arc minute is 1/60th of a degree, which is 0.1666. That's what I was trying to say. Arc minutes, not arc seconds.
Hmm.
0.166, I'm sorry. 1 arc minute is 0.166 of a degree. So 0.02 degrees is not 1 arc minute. It would be somewhat larger. Let me get that. 0.02.
I've just noticed another thing as well. This little light source that he's using has got a blue hue to it. Yeah, so it's a cold light of probably, I don't know, wait a minute, what's cold? So like 6500 Kelvin color temperature on the light, I would imagine. So it's probably an LED torch, yeah? He probably mentions it somewhere. But on the DSLR, his white balance is leveled for the scene, and it represents the scene quite well. On the iPhone, the white balance, or the auto white balance, is actually shit, and it's giving everything a crappy kind of hue to it that is very far away from the 60, well, let's just say 7000 Kelvin and this blue LED hue. So that's even going to wash it out as well. That's a big problem. It's going to blend things together. Unless you were properly white balanced, you get that color and contrast separation. You're just screwing with yourself.
Yeah. What I meant to say is that the 0.02 degrees, you multiply by 60 to get arc minutes, so that works out to 1.2 arc minutes. So you're off by 20% on that conversion.
Wow. Nice. Not me, you mean him.
Him, yeah. You is speaking in general.
Yeah. Right. That's wait a minute. Small things disappear. In order for an object, wait a minute. In order for an object to create an image. Wait, what? An object doesn't create an image.
What are you reading?
I'm reading is fucking. So I'm reading. So if you go to 6 minutes.
Right, 6 minutes. Hang on.
Yeah. So 1, things get smaller with distance. Don't need to cover that. There's no argument there whatsoever. And then.
Okay, his 3 point.
Yeah. So small things disappear. In order for an object to create an image, well, unless you replace the word object with imaging sensor. I don't know what it means. It must be larger. Oh well. All right. So, in order for an object to be perceived by the imaging sensor to go into an image, it must be larger than the angular resolution limit of the observer, such as the angle it creates between the focal lengths of the focal lengths f1, f2 is larger than the degrees theta radians and the diameter of the aperture. In general, theta can be assumed as 1 arc minute or 0.2. 0.02.
What he's using for theta is the resolution of the eye, which is typically taken as 0.02 degrees. That's not 1 arc minute, it's 1.2 arc minutes.
Yeah, so this is about diffraction, but diffraction on a camera lens, if you're on about, I think you might have this backwards. It's really late over here. It's like 2 a.m. in the morning.
Yeah, I know.
But
no, this 1.22 lambda over d, that's pretty standard.
No, I'm on about the f-stops here. I'm on about
the Rayleigh criteria.
Yeah, no, but I'm on about this. It must be larger than the angular resolution limit of the observer, such as the angle it creates between focal lengths f1 to f2 is larger than. So yeah, so he's doing a relationship between the aperture.
No, I don't think so. I think what he's doing here.
What's f1 and f2? No, these are focal lengths.
Yes, but
wait a minute.
Again, these flat earthers are horrible with their grammar.
No. So he's saying focal lengths, but focal lengths are actually measured in millimeters, and that's the distance between the aperture, the focal element's lens aperture, and the sensor.
I'm beginning. No, I think what he's saying is that's not f1 to f2, but it's f1 minus f2. Is, for example, I think.
Oh, right. Doing, okay. Yeah.
What he was talking about is you have your lens, you've got a focal point.
Yeah, okay. So he's absolutely wrong with this then, especially with that EOS 70D and the lens that he's got. Because on that lens, the diffraction effects that you would get from an extremely closed aperture would only come into effect at about f22. This is general knowledge photography, this. So So something at f2.8, you have shallow depth of field, all the way up to f16. Let's say you've got a really tight image and the aperture's closed, the iris is closed up. But it's only when you start getting beyond f22 that you start getting diffraction effects where the image starts getting softer. But it will do so at a very predictable and visible rate with everything. It will not be selective. So I'm not quite sure what he's on about here. This is... I might have to do a video, you know, to look at this more, I guess. But this guy is, you know, the
go-to guy.
Yeah.
Yeah.
Because
I think what he's trying to say in this particular point 2 is all he's basically saying, which is correct, is that the perceived angular measure of an object in a distance has to be greater than the resolution of the eye for us to perceive it as having any form. In that equation, theta in radians equals 1.22 lambda over d. If you take, say, the midpoint of visible light, say green, which is typically around 532 nanometers, and the diameter of the eye lens, excuse me, if you put in around, say, 3 millimeters there, then the
yeah, but none of this is 3 millimeters, Josh. The diameter of the eye is not 3 millimeters. Neither is
not the eye. The opening.
But George, a diameter of 3 millimeters, where you'd actually start giving a shit about diffraction with very small wavelengths that could affect it and effectively do, you know, cancellation of it, or you'd actually start to see the effect. You're looking, that only ever starts to come into effect at about f22, which is a shit ton more on a standard.
I don't know what you're talking about here. I'm talking about the eye, the human eye.
I'm talking about the aperture inside the camera lens, which is what.
No, I'm talking human eye.
Oh, right, okay. Yeah, but that's more than 3 millimeters.
It's no more than 5 or 6 dilated.
Really?
Right. Yeah.
I'm gonna have to try that one day. Yeah, possibly, but. But like I said,
that's where you end up getting the 0.02 degree resolution. Is if we work backwards. Let's just say to solve for D. I got 1.22 lambda divided by 0.02 degrees. I got to convert that to radians. So if I've got 1.22, and let's just say for visible light, let's use 500 nanometers. That's a little bit on the low end of the green. So 500 E minus 9 multiply, and then I divide by, take 0.02 degrees, divide by 180, multiply by pi, and divide that in. I get 1.75 millimeters for the aperture diameter. So it's in the ballpark. It's close.
I go to go to 8:05.
I gotta go for a few minutes, guys.
Khaled, I'm gonna end this in 2 minutes because I'm gonna have to go to bed. But cheers anyway, and I'll chat to you later if I'm not here when you get back.
Oh, yeah. On that Doppler, is in order to get a Doppler shift on a radio frequency or light or anything, you have to have relative motion. If two objects two spaceships are traveling together at the same speed, they can communicate back and forth without any frequency shift in their communication signal.
And that has nothing to do with relativity.
Not at that point. Not if the relative distance between them or the relative velocity between them is zero.
What, and they maintain distance, George?
And they maintain distance, yes.
Yeah.
They
Okay.
have to maintain distance if they're both traveling together at the same speed.
Well, not if they're going in different vectors, but yeah. They could be slightly moving away from each other.
Khaled told me that one is trailing the other. One's behind the other, and they're traveling in the same direction.
Yeah, yeah.
All right. Well, thank you guys.
All that matters in special relativity is the relative speed differences. There is no absolute speed. I mean, relative to the Earth, these two spaceships could be traveling near the speed of light, or it could be almost at a standstill, and have no relative difference in their velocities. So
wait a minute. Do you know what I think? Guys, do you think I know what we ought to do? What we ought to do is every now and then get a collection of videos whereby we can all have we can all go through and review them on a live hangout. We'll actually invite the person that did the video as well.
Sure.
Yeah. So
I'll be discussing special relativity later this week. I was supposed to do it tomorrow on Jose's hangout, but I can't make it. I've got to take Con into a vet early in the morning, and I don't think I can make it back in time. But I'm just waiting to hear back from Jose when he wants to reschedule it, and I'm going to be doing a discussion on special relativity and some of the consequences of it.
Cool. George, go to 805.
Yeah, I'd love that.
Yeah, I'm at 805, you say?
Yeah, the last paragraph, George.
Oh, okay. Just reading it. Last page.
Horizons are an optical...
Oh, wait. I got to get a little further up.
Okay, I'll have to go now. Dean, check the side chat of the Hangouts. I sent a couple of links. The moon size and orbit change visually.
Yeah, got them. Cheers for that, bud.
Yes, okay, thank you.
All
right, Khaled, take care.
You too. Bye-bye.
Wow, I didn't know that, Dean. Boy, you learn something new every day.
Yeah.
Oh, God. Horizons are optical phenomena, not physical curvature.
Yeah, and switching aperture sizes magnifies the image. How amazing is that?
By altering the horizon distance.
So it actually physically alters the distance between you and whatever you perceive the horizon to be. That's pretty... That's like
a good trick,
isn't it?
Yeah,
that's pretty awesome. Does that mean if wait a minute, if I stare at a football that's on the edge of scoring a goal, and I open my eyes really wide, do I get to push that over the line or something? This is going to be awesome.
I'm just thinking we have a new business model here for travel.
Yeah. Oh yeah.
You know, how we can travel throughout the world just sitting in your backyard in a lawn chair.
Yeah.
Just open up the aperture sizes if I want.
Well, yeah, all you need to do is just flash, put a flashlight in your eyes and do sort of like flash the light across your eyes and you'll be away.
I can see Dean in his backyard.
Yeah. No, this is I think those last two lines there that means you don't know what I'm now questioning that he must know that aperture size actually has fuck all to do with focal length. He seems to be getting the two mixed up, because when he says the focal length f1 and f2, they are not focal lengths. That's the aperture of the that's the aperture of the iris inside a camera. Focal length is
who knows what the hell it means. Again, this goes down to what I'm always contending. I get so mad at a lot of the comment sections videos is these flat earthers, their grammar is atrocious a lot of times.
Well, this isn't
about a hard time interpreting.
Yeah, this isn't about grammar. This is he's using.
No, but again, how they construct sentences that they just don't make any sense. sense a lot of times, and you got to sit stare at it and try to parse it out to figure out what the hell they're trying to tell you.
Yeah, unless, wait a minute, he's getting the 2 focal lengths away. Yeah, f-stops are not focal lengths. It's just ridiculous what he's saying. But anyway, yeah, no, yeah, I think it might be an idea that, you know, we sometimes look at this, because I'd love to do one for that ranty
what
video.
I think he's trying to, again, in number 2, what I think he's trying to say is that you have a lens between the observer and the target, okay?
Mhm.
You have the light coming into the lens. It's going to now bend down to a point, to the focal point, and then beyond the focal point, it's going to expand to get a reverse image. Now, I think he's talking about, say, the distance from the lens to the focal point is maybe being f1, and the distance from the focal point to your imaging sensor or whatever being f2. And you're looking at the difference between, I don't know. That's all I can, because he mentioned something about that in the video.
Yeah, so what actually happens is if the f-stop, so yeah, I think I'm getting confused, because it should be relating the two, not calling f-stops focal length. Because if I open up the aperture to maintain the same focus point,
well, I'm not so sure he's talking about aperture size here, or indeed he is intending to talk about focal lengths from the lens to the focal point and then from the focal point to the target. I don't know. Again, he's not very precise here. He's very confusing.
Yeah, but how the hell he actually assumes all of this based off a iPhone camera that he cannot control, when that is the only one that exhibited this problem?
Yeah.
That's a logic flaw right there, to be honest.
Yeah, before you go, I want to put this out to you that I put out to Rumpus a while back, and this relates to here when we first started. We were looking at the 2 different lens sizes and the fact that there's light that goes into the larger lens that the smaller lens misses. And this is something that's bothered me, because a couple of years ago I was looking at building a scale size section of a spherical Earth in a huge snowbank, okay? And then zooming in, moving in with a camera of to say you start out away several diameters away, and you can see the curvature of the surface, and then as you move in, the curve is going to start flattening out to where it just looks like a straight line, a straight horizon. Now it's going to do a video to show that, and then I got to thinking about this. This really bothers me in the sense that, say, with the human eye, we have a lens aperture of somewhere between 3 to 7, 8 millimeters, around 8 millimeters when the eye is fully dilated. Now we're doing all these guys are doing all these tests and experiments using a camera that has an aperture of about 2.5 inches across.
No.
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 Why?
Because the aperture is not measured by the last lens element. It's obviously a multi-blade iris that's inside. So.
But would not the resolution of the camera ultimately be affected by the object lens?
Right. So you have many different groupings of lenses that control the light inside.
Yeah, but I mean, as far as diffraction limit and all that, that seems to me that would be set by your object lens, no?
Right, wait a minute. Maybe I'm missing what you're saying right now, and it could be because it's now 10 past 2 in the morning.
Yeah. Well, we can revisit this another time.
Yeah, no, I don't. Yeah, I don't mind having this thought. And like I say, I think it'd be quite cool to get some of these videos and just like invite some people onto the panel where we can discuss what the problems are with them.
See, well, do you still have your little diagram where you have the two lenses and you have the light rays going? That remember that earlier?
Yes, George, and I could potentially redraw that in a couple of seconds, even if I didn't have it. So, give me a second. Because I've got to also share this a few places. Yeah, so what you've got, I'm actually going to free draw this now because we're only talking about one thing. So, yep, that. Yes, that. So, so we have obviously lens. Oh, Jesus Christ. Okay, George, you left. Well done. Does that mean I can go to sleep without drawing lens elements? If you're not back in 10 seconds, I get to go to sleep. Bend this. Yes, thank God.